All right, so we're back here, and so let's talk a little bit about some problems, how to solve them, things like that. So we'll start with, I already wrote it down, number 8.13 on page 352. And this question is asking us, if we had a clinical study, right, we had 3,900 people that got a vaccine, for vaccine. And so with this vaccine, right, we know that over 28 weeks, after getting this weight, 24 folks got the disease. So find the point estimate of the population in proportion that were vaccinated with the vaccine but still developed the flu. So how many people got it after doing this, right? So part A is like, what's the, how many got sick after getting the vaccine? How many sick? So this one, pretty straightforward. It's going to be 24 divided by 3,900, which is going to be equal to 0.00615, right? Part B asks a different question. So find the standard error of the estimate, right? So recall that the standard error formula is going to be so it's going to be P multiplied by the complement by its complement. So this is the estimate divided by N is that, right? So if we move into this next step, what would this look like? We would look at, this is basically going to be 0.00615 times 1 minus 0.00615. And based off of what we know from the study, there were 3,900 people. So we would divide that by 3,900, put it under the square root symbol, and we would get the standard error is equal to 0.00125. So then it's asking us for part C, what is the margin of error? So this is not the interval, right? It's just saying what is the margin of error. Very, very key distinction there. So the way that we would find this, right, is we would do, if we're finding for like a 95%, so that is key, right? So for 95%, we know that's 1.96 times 0.00125, and this is going to be equal to 0.00245. Part D is asking what is the interval, the confidence interval, what is the CI. And so if we do this, basically what we're saying, right, is would include all proportions within one margin of error. So that's what we're trying to find, right, at 0.00615, blah, blah, blah. So this would be, if we're finding it underneath, so it would be 0.00615 minus 0.00245, and this is going to equal to 0.0037. We would also do 0.00615 plus 0.00245, and this will equal 0.0086. And so we get this CI is equal to here, so it'd be 0.0037 colon 0.00 0.86. And that would be our 95% confidence interval. So the way that we would think about this, right, our interpretation is that we are 95% sure. If we like point this out, it would be 0.37% to 0.86% of people, of vaccine receivers would get sick again. So that's what we've kind of found. And then it's like, can you conclude for part E? Can we conclude that fewer than 1% of all people vaccinated with the vaccine will develop the flu? Our answer for this is yes, because the upper bound and for this, right, is 0.86% is less than 1%. So, not so bad, right? Like pretty okay, I would hope. So let's do another one. We'll do number 8.14. How green are you? So the survey is asking people whether or not they'd be willing to accept cuts in their standard of living to protect the environment. And we had 344 people yes out of 1,170 total. So question A is estimate the population proportion who would answer yes. Okay, so number A, hopefully pretty straightforward, is going to be 344 over 1170, and this is equal to 0.294. If we go to part B, find the margin of error for a 95% confidence interval. And so we'll use our formula again. Again, this formula is p hat minus 1 times the complement of p divided by n, and put a square root underneath it. And so if we did this right, this is going to be 0.294 times 1 minus 0.294 divided by 1170, because that's how big our sample is. And what would we get if we did this? It would be 0.013 for the margin of error. And then to get that, so that's the first part, multiply this 1 times 1.96, and this would equal 0.025. For part C asks us, find a 95% confidence interval for that proportion and interpret. So we would use 0.294, excuse me, 0.294 minus 0.25 equals 0.27. This would be 0.294 plus 0.025 equals 0.32. And so like this interval is going to be, so basically we would say the CI is going to be equal to 0.27 colon 32. Put our brackets around that, and we're moving on, right? So then it's asking us a different one. So kind of what are these assumptions? How do we check for them, right? And so we have to assume a random sample. And large enough to estimate. right? And, so this would be like the 15 success, 15 no. We can say, yes, we achieved the conditions. We'll do, let's see, which one? We'll do 8.19 real quick. Whoops. Come on. Come on. What's the matter?